Great. So thank you all, investors and startups, for being here today and joining us for this edition of the Startup Tank. My name is Michna Filip. I'm here with my colleague Echo, and we work with Matt at Forward and Climate Techies, really to build a online, global, and local climate community and accelerate collaborations and connections around the world, technology areas and sectors. So we're excited to have a few pitches today from climate tech startups joining us. I'll give the chance to our investors joining us today to give a quick intro, and then we can get into the pitches where we suggest keeping it to around
Well, I guess, Dennis, do you want to maybe give us a few words to introduce yourself and we can do round robin?
Sure, sure. Been there before with technical difficulties, so no worries. Good morning. I'm not sure where everybody is. Maybe good afternoon, good evening is in order. My name is Dennis Clark. I'm an investment director at Zeon Ventures. Zeon Ventures is an early stage investor across sustainability, climate, advanced materials, and human health. We're primarily doing Series A and B investments in companies in North America. We also look at Europe and Israel and other areas as well. We are backed by a large corporation, multinational elastomer, polymer, and specialty materials company, also called Zeon Corporation. And you may not know Zeon, but there's a good chance that you've touched a product today with Zeon materials. So the screen that we're looking at today, the display could have optical film from Zeon. The car in your driveway could have EV battery materials from Zeon, or the tires, or interior parts as well. So broad exposure to automotive, consumer electronics, and healthcare and life sciences. We've done quite a bit of investments in this category, focused a lot on energy transition and batteries specifically, but we are broadening our scope and looking more broadly at bio-based materials. Solar and renewables is also a topic. So looking forward to the presentations and conversations today. Thank you very much.
I should say that Dennis has already received all of the decks that are about to be pitched today. You may have updated information from the version that I sent out, though. Okay, so I guess I I'm the host, so I'm just gonna pick somebody to pitch. Chris, do you want to go first?
Yeah, sure. It's just fun to see Zeon Ventures. Yeah, we know of Zeon a little bit because we've worked with Mitsui Chemicals on the films for making solar panels. So uh, there's multiple folks out of Japan. That's good for everybody. So just a fun side note.
Great.
But yeah, I'm
Yes.
happy to introduce what we're doing. Oh, sorry, let me
Sure.
speaking of technical
In full
difficulties, make
disclosure,
sure I
I
get.
got the materials very late last night, so I just took a brief look. So yeah, looking forward to the presentation.
Well, hopefully we can do value add by the presentation. So all right, let me get my screen full. Yeah. All right. Well, great to be here all. We're Sunspan, and we're literally trying to reshape the solar industry. So that's what we're here for. The issue is that solar panels have actually gotten so low cost in recent years that there's not a lot more room to squeeze system costs out by making the solar panels cheaper. There just isn't much more room to go. What you're left with, especially in things like parking lot solar for commercial and industrial, is the remainder of the system. It's all the steel and the concrete and the labor associated with that. That's where the cost is. And if you want to make these systems more cost effective, you're going to have to attack that. So, how do you do it? Well, we go back to first principles. And it's been known for a long time that tensile structures are really the best way to build a lot of things. That's why the Golden Gate Bridge looks the way that it does. What we do is we take our special solar tubes, which I'll talk more about in a second, and we can suspend them from cables to get full coverage over a parking lot. And essentially, you make the panel come the structure, so that saves a lot of cost. And in particular, there's no foundations needed. So the room to save cost in a finished system is 5 times larger than if you could make regular solar panels free. You just can't move the needle, but with the panels, you've got to focus elsewhere. So that's what we do. Now, the tubes themselves, I've got a section of one right here that may show up with the background. They're relatively straightforward to make, but there's some IP around the details. And their consequence is that they're aerodynamic. Wind is the thing that drives those support structures I was showing earlier, and a lot of the cost. So if you reduce the forces to begin with, you've immediately made your job easier. The tubes also have solar cells across the top, which means that you get one-axis tracking behavior. Normally, that's only in utility scale arrays. We shrink it down so it can go anywhere, and we do it with no moving parts to generate more energy. Something that we didn't know as much before we started testing is they actually stay pretty clean. Even in dry climates like California, condensation and dew tends to pull dirt down to the bottom out of the way. And we can accomplish all of these goals using only the same kinds of solar cells everybody else uses and low-cost materials like glass. So we get the cost advantages and we put it all together. What that means is that for the end customer, you can get more megawatts out of your parking lot, and each megawatt generates more energy each year because of the tracking, and the whole thing costs less to build. So this kind of quantum or step change in the cost of the system, what it does is it takes it from being a compliance play at the local elementary school to being something that Walmart actually wants to do. And because it's a bit lower cost than the utility, and it proves out in a bunch of different geographies. So we're going to take the currently kind of $1 billion a year market, and we can multiply it by 20 or 30 times when it's actually cost effective. Now, I focus primarily on commercial and industrial because that's the most established and sort of well-known market. But our technology has different unique benefits elsewhere. On farms, we cast very even shade, which is beneficial to plants in hot climates. We've tested this out to get 50% more crop yields just by taking away some of the harsh sunlight in places like Arizona and California. And for floating, these tubes, again, they're hollow, so they float perfectly well. And we've tested with the National Science Foundation how to float them directly in the ocean for 6 months. And they did perfectly fine. The cheapest support structure you're ever going to get is the one you didn't have to buy. So if we do this, each one of these is an enormous market. Progress that we've made to date, as I mentioned, the Department of Energy funded us to do ag studies, the NSF funded us to do floating studies, and we've gotten grants from the California Energy Commission. So that's been the majority of the over $1 million that we've raised. We've also gotten some money to do things like file patents, of which we have a number. And I'm most excited about the letters of intent that we have, primarily from Cherry Street Energy, which is a solar developer in Atlanta, focusing on parking lots. And they really, really want some cost savings so that they can pass them on. But also the multinational energy company Eon, that many of you may know. They get multiple requests a week for megawatt scale parking lot solar arrays, and they want to put up our panels at their headquarters as a sales tool so they can sell on to their end customers. Our business model is pretty straightforward. We're fabless using contract manufacturers. It's the same thing that Apple does. And we'll manage the sort of central functions. And our partner ICSN, they're not a household name, but they do have an international presence. And yeah, you've probably encountered products that they made stuff for GE and Bose. So you've almost certainly encountered some of their stuff. But they're small enough, they've been really helpful and they've kind of taken us under their wing. So they're a great partner we're very proud about. Our financials are up and to the right as they should be, but I want to point out two things. One is that we can get to EBITDA positive pretty early. Solar panel manufacturing is actually an unusually capital light activity to do. And a lot of the stuff we do is similar to other solar manufacturing. There's a few automated tools we have to make, but it's not drastically different and it's not more complicated. Also, the solar market is so huge that just the C&I space represents an enormous opportunity. And even as we get into the hundreds of millions of dollars per year, it's still only a few percent of this market. There's a lot of room to run. Our team is really strong. David and I are fortunate to be very well educated. And I've worked in solar for a long time at a bunch of different companies, and it was triangulating between those companies' technologies that helped me come up with the Sunspan technology. I also worked at Amazon on hardware reliability, which turns out to have been a very good experience. David is both an engineer and an MBA, which is really interesting and useful. And he's been working on clean energy since the 90s, so he's great. We've now recruited a team around us that has a bunch of experience in a whole bunch of different fields, whether it's energy storage and EVs, things that we touch on, but also solar. So as I say, collectively, we have a century of experience. And what we're trying to do is right now raise a seed round. And what that's going to accomplish is to build 2 pilot arrays for Cherry Street and Eon, get the UL certification we need to make large scale sales, file a couple more patents. We don't need 50, but a few more would be helpful, and book our first $5 million in sales, which would be the kickoff for our Series A. So that's what we're doing, and I'm happy to answer any questions. Thank you.
Great. Thank you very much, Chris. I really appreciate the presentation. And I guess, Echo, correct me if I'm wrong, am I the only investor on the call today?
Yes, you are.
Okay,
So,
got it. All right.
yeah, it's up to you to ask whatever you'd like.
Okay, thank you. Yeah, and timing wise, we have about 5-10 minutes per guest. Okay,
Think,
excellent. Thank you.
was it 10
So,
minutes of questions? If I was on time, I thought I was.
Yeah, you were
got
good.
it.
So yeah, 10 more
Excellent.
minutes.
Well, thank you again for the presentation, Chris. Yeah, actually, as you alluded to, Zeon, we're in the optical film business for display, and we actually have an encapsulant material that we're working on for solar specifically. So this is an area of interest. First, I'm kind of curious around the architecture, and if you could dive in a little bit deeper on, you mentioned this kind of tensile structure. 360-degree tube seems a little bit counterintuitive in a way because at some point you're going to have part of the panel or tube facing an area where it's not getting direct sun. I assume maybe if it's a parking lot, it's getting reflections or whatever. But can you talk a little bit about the genesis of this idea and dive a little bit deeper into the technology itself versus a typical panel?
So the history behind it is there was a famous company that dare not speak its name that was working on tubular solar about 15 years ago. And I worked there, and it was actually super interesting. We saw that they sold hundreds of megawatts to very happy customers all around the world. And I remember being very, very struck by how much people loved the tube shape because it was aerodynamic and it provided solar tracking. But the way that they manufactured it with thin films, because they were thin film guys originally, the tube shape for them was a side effect, not the central feature. And that ultimately, unfortunately, killed the company. And there's been a whole bunch of political backlash. I won't rehash the history, most of it not accurate. But the point is, the tube shape was beloved. And what I struggled with after they went under, I was like, God, people really love this. It was so valuable. There has got to be a way to put silicon cells inside a tube. It's not as simple as it sounds, but there is a way to do that. And that's why I'm holding the thing that I'm holding right now. And that comes back to adhesives. But the short answer is the tube shape is really beneficial. But the key enabling technology for us, and that's why it had to wait until the late teens, was bifacial solar cells. So I only have to cover most of the top half of the tube to collect light from all directions because the backside of the cells that you're now looking at they're now sensitive, and they weren't until a couple of years ago. So this had to kind of wait until this new technology came out. But once you do that, you can now collect, especially across the top arc. That's where most of the light comes from. But there is light coming back up from the white fabric that we're going to hang underneath. That fabric, just I should mention, does two things. One, it provides light coming back up to boost how much energy each tube collects, which improves your cost per watt. But it also provides the full shading for the cars. Unlike a parking garage, however, it is translucent, so it looks bright underneath, even though it's only a couple percent as much power as you'd have under full sunlight. So, but it's visually bright, so you're not going to run kids over. But it's also not going to make your car hot. That's why we have the white fabric and we want the tubes. But because of bifacial cells, you only have to cover about a third of the tube to get almost all the light.
Got it. Interesting. Yeah, that makes a lot of sense. And then just drilling down on the manufacturability that you mentioned, when we think about, what's the process for doing this and how does it compare to, again, a traditional panel? You mentioned you're fabless, so you're going to be, outsourcing the manufacturing to someone that has prowess in that
Yeah.
area.
Well, so we're lucky. I don't have a good slot on manufacturing for IP reasons, but we've worked with ICSN because of these grants. We've had occasion to build several generations of tubes. And a lot of the steps are the same as everybody else. Connecting the solar cells into long so-called strings, which we do with shingling, but connecting them into strings, doing a lamination operation onto a back sheet. So now you have an object which can be placed inside a tube. That's the only thing that's a little bit unusual, is that there's a second lamination step of the cells against the tube. As far as we can tell, that seems to cost about a penny per watt. So there may be a penny per watt penalty we have to pay relative to everybody else. If you're saving $1.50, not a big deal, but that is the one area of difference. The good news is we have built 2 generations of that tooling. It's not fully automated, but the tool that does all this job, we've built several generations of it, and we're working on number 3 right now. But it's been pretty straightforward. This tube, and again, if I could show you in person, it would look a lot cooler. There's a way to attach the cells inside the tube. But I actually am interested in discussions with polymer manufacturers. We were just talking the other day. Dow's great. They've been helpful. Their lead researcher was able to give us some pointers, but they haven't been super involved in work since. So we're interested in more activist parties who can help us with some polymer stuff. In particular, the curing sheets that are used for adhesive, we'd like to get it in an unusually thick version. We do have to fill some space between the curve of the glass and the solar cell itself.
Interesting. Yeah, there might be some synergies there with our parent company.
Yeah, we do use a little bit more than everybody else, but it's not a major cost center.
Great. And then just in general, what's your outlook on the market for this type of application of solar and commercial solar? I know we've had an incredible trajectory in terms of growth rates, particularly in the US over the last few years. We may be seeing some softening just due to commercial real estate and just kind of some of the issues around that. How are you positioning yourself, kind of given the current state of the market?
Yeah, well, for sure. The good news is that there's a lot of international demand. I mean, the US has more parking spaces than everybody else because, well, we're America, but there's a lot in Europe and Japan as well, which actually Japan's really interesting. They've been one of the leaders in agri-solar, so that's something that we're hoping to do in the longer term. But Europe is really agri-solar and parking lots. I should note that, yes, the US is at least temporarily going through a bit of a bobble, but the nation of France, as some of you may know, passed a law about a year ago saying that every large parking lot must have solar by the end of this decade. To run the numbers, that's about a $40 billion opportunity. So I think that'll be very helpful for us. That's part of the reason that Eon, which is based out of Germany, is so excited. But even above and beyond France, Czech Republic is literally spending national security money to build parking lot solar arrays to try to get off of Russian gas. So one possible strategy for us is to focus more on the European market than the US. But the good news is the US market's also solid. Even just doing compliance plays, and again, it's usually the local elementary school, not the local Walmart, but even that's already $1 billion a year. If it softens a little bit, that's plenty of room for us. But in the long term, I think it's going to be tens of billions of dollars a year. Because the technical potential, and this is kind of obscene, but like the city of Phoenix has 50 square miles of parking lots. Los Angeles correspondingly more. Like the room to run here is kind of shocking. You can produce about a third or a quarter of US electricity just from our parking lots. So it doesn't have to fill the whole thing to make a very exciting business. And that's how we view it.
Got it. And then just a final question for me on the pilots that you mentioned. So you're raising the seed round. Sounds like you have 2 pilots planned. What are the milestones? What are you hoping to achieve in those pilots?
Yeah, we've talked to a number of
how long of a
Oh, please.
No, just in terms of like understanding the pilot itself and what you're looking to achieve, and then what will be the next step after that.
Yeah, so we're fortunate to have done the I-Corps program through our various grants. And so it means we talked to a lot of customers. And what we've heard from a number of people, and when I say customer, I mean solar developers who are going to incorporate our hardware. But what we've heard from a lot of them is, hey, can you demonstrate this for even 3, preferably 6 months in the field, just so we can see it somewhere and get it out there? And so 6 months is kind of the goal. And yeah, getting into the next level of detail, part of what we're funding towards is just staying alive for 6 months and keeping the team going and all of that so that we can demonstrate this to customers. The only, I guess, upside of that 6 months is that's about how long it takes to get the UL certification anyway, because there's some heat soaking that has to go on for 2,000 hours and all that. So you can do these things in parallel. And what it would mean is if we were to raise our money shortly, then we would build the panels, get them out there for the sort of second half of this year. And once people can go see these arrays, again, one in Europe, one in the United States, they can go walk around underneath them, see them perform for 6 months, and then we'll have a certification. We would take orders early in the new year. It's kind of how we're thinking about it. And then Series A enables us to build a larger scale factory to start producing many tubes rather than hundreds or thousands. It's not super complicated, but we do need to build some factories. Thankfully, however, just the cost of those factories is pretty low. Regular solar panel factories typically cost 10 cents per watt of capacity. So if you want to build a gigafactory, it's only $100 million, and it lasts 5 years. So the capital cost portion of the final product cost is unusually low compared to other manufactured products.
Got it. Great. Thank you very much. Really appreciate the information. I would love to have a conversation offline and learn a little bit more
pleasure.
About needs on the material side as well.
Well, it's something that's of great interest to us, and Dow has helped us with some early stuff but we're kind of looking for a more, as I say, activist partner. I did want to ask Echo, You mentioned about different places one could paste contact information and Calendly links. I can certainly add that to the chat, but there was something about the YouTube channel as well.
Okay, I can make an intro offline.
Okay, that'd be great. Well, I'll go
Yep.
ahead and add it to the chat if that's all right here. I just wasn't sure about the YouTube and LinkedIn that they had asked about.
Yeah, the chat is not visible on YouTube.
Okay, cool. All right, good to be here.
Okay, well, I'm going off of first initials, so Dan, you're next.
Hello. Hello, everyone.
Hello.
Thanks for your attention. I'm Dan Balanovsky. I'm the founder of Antubay Smart Energy. I'm an industrial engineer, having 15 years experience developing in the telemetry business. And my partner is the co-founder, Rodolfo Casabon. He's industrial designer and he has 20 years working in the energy business. We established Antubay in the year 2021 in Spain. We have 2 part-time electronic engineers working as a development team, a software factory partner in Barcelona, and all our hardware production partners are located in China. We designed from scratch an energy management system which include hardware, as you can see it on the left side, and a software solution to provide real-time information. This device is installed in different type of sites. We call them telecommunication nodes that are supplied by renewable energy. And let's see how it works. Here we have the DC box device. First we need a power supply. This supply could be solar panels, wind generators, or even AC-DC converters. This device receives energy and provides a non-interrupted power to device connected in the output, and it also charges the battery bank to use it when there is no sun or there is no wind or any power supply is interrupted. At the same time, our DC box posts periodical events with all operational energy information to our software, and also prompts early alerts in case of events. These early events can be also sent to our phone number via Telegram. And this device, we designed it replaces 4 different devices are being used today in the telecommunication sites. It represents a 30% saving in hardware investment, saves a lot of space, and also reduces operational risk, having only 1 device instead of 4, and extend the battery life. This is how our device looks like. It's pretty much similar to a Wi-Fi box, and the first production batch is being produced right now in our factories in China. Here we have a couple of screenshots of our software. You can see it, a general view when you receive the energy status of each node. And if you click on details, you can see here the energy source and energy consumption history of each node. And in the bottom you can see the real-time energy input, output, and what's happening with the battery status. Our target markets are all different type of applications, from boards to traffic control and information systems. We think that every off-grid site that needs DC energy is a potential customer for us. And talking about numbers, here we have our forecast in sales for 5 years, which includes hardware sales and software subscription. We expect to have 15,000 devices sold in 5 years. We decided to go in a B2B model via distributors at each region, and we expect to have an EBITDA of 41% and a net income of 33%. Well, this is it. Thank you. Thank you very much.
You had 2
Great.
more minutes if you wanted to tell us a bit more.
No, don't worry. It's okay. I'm ready for the questions.
Okay.
Yeah, thank you very much, Dan. And I guess full disclosure, this is an area I don't know a lot about, so excuse me if there's a little bit of an education process. But can you talk a little bit about this solution? Who are you selling into? Who are the main customers?
Okay.
What solutions are they using today?
Well,
yeah.
Yeah, actually, mainly we started this for telecommunication antennas and cameras where there's off-grid, where they don't have power supply. So we will focus on a solar panel to provide all the energy to the camera or the antenna. Maybe it could be a Wi-Fi antenna, could be a telecommunication antenna, and we also use our device to extend the battery life because it keeps the battery on floating, and then your battery doesn't make it increases like 2 or 3 times the battery life, lithium batteries. We started this here in Argentina as a target, because I live here, so we made this solution for one customer, and then we extended once the product was solid enough. We went to China to get the PCB manufacturer, and we designed also the displays and all that stuff.
Got it. And so there's a hardware and a software component to what you
Yeah,
do.
yeah. Each our hardware, it has an Ethernet cable, and it also has Wi-Fi in case you have within a one, or you can put a LoRa or an Ubiquiti device to transmit to post all the information. We also modelize our software in IoT software, which is where we have a state, and we forward all these messages to your phone in case you need some operational early alerts and some vandalism happen or some temperature in the site get risen, so you can in advance go before the breakage, before the camera finished working. You can access to it and you can fix it.
Got it. And so in addition to monitoring something in real time, are you using any type of machine learning or AI to be able to predict performance or optimize things? Is that part of the service that you're offering?
Well, actually, today we post all alerts to the operations manager's telephone, and he decides what to do. Previously, we have been integrated with some PLC and telemetry devices, like a GPS device, and we use them to transmit all the data. Then we integrated that functionality inside our device, and this is how we save money for our customers, because we provide a 4-in-1 solution. Today, all installations uses up to 5 devices, like an MPPT, a DC power converter, a PLC, an energy meter, and a telemetry telemetry device, which is very huge, and you need a lot of space. So we reduced that to one single device, and we think it will be a revolution for the telecommunication industry, because this doesn't exist today.
Got it. Sorry. One quick question from my side, and it sounds like Chris has a
Yeah.
question. How large is this market? How large do you estimate this market? So it sounds like you're providing a new service. You're not trying to replace something that exists in the market today. How do you?
Yeah, I understand. Actually, we are replacing 5 different vendors. We think, let me show you here. For example, all boards that are in Europe today installed need this device. So today we have a huge market in Europe. Actually, in Africa also, because there's a lot of off-grid installations, but we will plan to within our business plan is to make a very deep market selection, because it's so widely that only for for Spain and Portugal we expect like 2,000 to 3,000 devices. And it's become huge if you go to US and you go to the rest of Europe. So part of our investment is to go deeper to each segment to measure it, because it's something that we have a great success in one small market in a very far away country in Argentina, and it's great, but now we need to make it real in a big scale. That is why we went to China to produce it, because we need to move to have a huge rotation of the product.
I didn't mean to interrupt, Dennis. I was just curious because it could come up in the future for us. So this is selfishly I'm asking. When you have like an electronics box or
Yeah.
with some software, how do you protect it from competition?
Protected from competition. Well,
Like a patent or something?
actually, we've been working for 3 years to make it happen. So we are 3 years ahead of the rest of the people. And of course, we will patent it when the time it needs. Actually, I personally think that it's like another challenge, because after this we have high power devices to address and to develop, and then hydrogen telemetry, which is it's electronics. In 5 years you are old, so I don't think a patent will make me a difference. My difference will be to get customer requests done fast and with a high quality person. It's my personal belief.
So you have this existing business within telecommunications, and you see an opportunity to expand it to other areas that are kind of off grid and have similar needs. Can we just dive in a little bit deeper on the current customers? So you have some paying customers, which is great. Like, who are they? Are they the telecommunications
Well,
companies directly, or
yeah, actually we have one pilot device, two pilot devices working in here in Argentina. It's a telecommunication company, and they are testing it. They are testing it. They are asking questions. We already finished the beta testing. So this device I showed you is the first production batch with all the updates and upgrades we've done. It has Ethernet and Wi-Fi by customer request, and we expect in the near future to have a second family of devices with LoRa, what is very useful for Europe. But it's a development path. We are mainly all a company of engineers, so we love to develop. So we'll be focusing on all what the customer requests, and it's a very fast growing market.
the pilots that you mentioned?
Yeah.
I know I think we all on the call know how challenging it can be to get pilots with customers, paying customers. What did they see in what you're doing to get them excited, and what are their expectations?
Well, actually, the main challenge is the real-time information they need for their operations, because today all the maintenance is being done reactive. Let's say they figure out they lost communication from one of the antennas, and they run away to see what's going on, and it takes like 1 hour or two to get to the antenna, plus another an hour or two to fix it. With this type of system, you have early alerts. You know if the battery is being out of energy. You know if there is some breakage in the energy source, or any problem in the antenna, because it has sensors. You can put a different type of digital and analog inputs, so you can measure humidity, temperature, any vandalism if you have a magnetic sensor. So you have you know what's going to what is happening before the customer calls you to say he doesn't have internet. So people are very happy about that. and they are requesting a lot of additional features. So we are stopping them to to cut the requirements and say, okay, this is going to be for today. This is going to be for the next generation, because we don't have enough muscle to do it quicker.
Got it. Yeah, I'm painfully aware of this issue. Actually, this weekend we had a storm and a power outage and internet down, and it's funny how your whole world comes to a screeching stop when you don't have telecommunications access. So yeah, I definitely understand the pain point. Last question for me is just on the business model over the long term. Is this something you intend to continue to build and scale out and find partners to build? Would you license this? And then how are you making money? Is it, I assume it's sales of the hardware and then some type of servicing?
First you have the hardware, which is, it goes via distributors. The customer that buys this device is the guy that needs to set up all the antennas. So the guy goes to buy the solar panel, he goes to buy the cables, he goes to buy the camera, and he will also go to our distributor to get our device. This is one source of income. The other source of income is the subscription. The guy who wants to monitor 15 nodes, he will have a subscription for 15 nodes, and he will pay a monthly fee to get access to see how his node is working. This is the two ways of income we are thinking about. The other family, which has a higher power solutions, it's much more project based, because it's for stations and electricity companies. This is another business unit, let's say, because it's tailor-made solutions. But this is much more massive, let's say. We expect to have a lot of videos and also installation manuals for the guys that purchase this solution, and they need to quickly install it, because we need to teach people how to use it and how to install it, because this is new. This is the biggest challenge for us.
Great, thank you. And then how about, I guess, rounding out here, the ask, sounds like you're looking to raise outside financing. Have you raised money already? Is this would be like the first outside money you're taking? And how much are you looking to raise?
Yeah, we invest, we ourselves, the both co-founder, we invest on the engineering and the production of the first production lot. The money we are looking for is for starting the company. It's for starting selling people. We have like 50 to 60% for production, 40% for people, and 15% for developing, for engineering and developing. This is the way we will split the investment. And it's okay.
Great, thank you very much. I appreciate it.
Okay.
Okay. Last but not least, John, it's your turn.
Great. Well, we'll just get right to it. So, is that showing up full screen for everyone?
Sorry.
Yes.
Yes. Yep.
Okay. So it's up. Okay, let's get started. So, my name is John Lin. I'm co-founder and CEO of Tau Carbon. We remove CO2 from the atmosphere by storing dry, densified wood waste, which looks like these bricks here. Can I advance this? Sorry. We're in the CO2 removal industry, also called CDR, and it's growing fast. It's growing fast because CDR is the net in net zero. You get to net zero, you're going to need to remove billions of tons of CO2 from the atmosphere every year. And that's why McKinsey is projecting a 2030 market size of $40 to $80 billion per year and $1 trillion per year by 2050. And if you just look at the value of credits sold in the past year, it's gone from $240 million in 2022 to about $2.2 billion in 2023. Our solution leverages photosynthesis. So trees are going to capture CO2 for free and convert it into wood. And now in the American West, we have this need to remove extra trees from forests to mitigate wildfires. We collect that wood waste on the scale of millions of tons, and then we move it a short distance to one of our storage sites and process it. And that means chipping it, drying it, and densifying it. And then we have a choice. We can either put it in dry storage in containers for more than 100 years or sell the briquettes now. If we sell CDR credits, that price is over $100 per ton of CO2. If you're selling just the briquettes for use now, we make a nice margin. The wholesale is about $500 per ton. It only costs us $60 per ton to make them. And then outside the United States, Tao wouldn't be in the business of owning and operating its own sites. It would franchise. So we package our methods, our intellectual property, and our brand, and let franchisees use it overseas and take royalties. Competitive advantages. So the big one here is that if you dry out wood and you keep it dry, it doesn't decay. So you're going to have carbon locked up without any worries, as long as you keep the humidity below 85%. It's low cost. We're at about $50 per ton of CO2 at a full-size site. Like I mentioned, we're going to expand overseas with franchisees. That means high margin royalties. We have a high storage density. If you got a container that's about 2 stories tall or 6 meters, we'll put 40,000 tons of CO2 equivalent on a single acre. And the MRV is straightforward because the wood is right in front of you. It can be monitored, accessed, physically sampled. And that means less uncertainty for credit buyers. We have IP. This is a highly engineered solution. So we'll be filing that provisional imminently on our container design and our drying method. And of course, in the seed round, that R&D goes on. So we'll focus more on densification, how the briquettes stack up, and MRV. That means monitoring, reporting, verification. We have competitors in this space. This may be unfamiliar given this audience, but there are people who want to bury wood underground. There are people who want to sink biomass to the bottom of the ocean. And there's biochar. And then there's one that's just come out called graphite. This is funded by Bill Gates's Breakthrough Energy Ventures. They're making essentially the same briquettes we're making. They wrap them in plastic, they bury them underground. But all these competitors have problems. One, there's CO2 leakage and methane leakage from their systems. They have MRV problems. They can't really monitor what's going on. And they're affecting the environment in a huge way. And we don't. Tao doesn't have that problem. So we've been in our pre-seed round. We raised $1 million pre-seed in March 2023. We now have a methodology to sell carbon removal credits from Puro.Earth. That's called the terrestrial storage of biomass methodology. We've worked with our container vendor, that's Fiber Technology Corporation, and our engineers at Dell to redesign their water tanks, which are made of fiberglass and also called FRP. Redesign those for wood storage. We have a working prototype that's at our site in Alameda, California, and we've signed an LOI for a 10,000-ton pilot this year. This is with a reforestation company that we can't name yet. This is the founding team. I'm the CEO. I'm a former lawyer turned chemical engineer. Our CTO is also a chemical engineer. We crossed paths at Stanford when we were in the same research group doing CO2 to fuels research. We realized that this wood storage was just a huge untapped opportunity. Dr. Yanda, our CTO, also has experience at Dow and Clorox, and our COO, Justin Kreindler, has operational experience in the nonprofit sector. Scale and unit cost projections. Obviously, we'll scale up as quickly as possible, but what matters more is how quickly we're getting our unit costs down. So you can see we're starting at $300 per ton, getting down to $50 per ton within 5 years. And that's being driven somewhat by just moving to larger sites, larger containers. But we're also going to incorporate lower cost panels because our current vendor is a relatively high cost producer. And then we shift to lower cost locations overseas where everything's cheaper. Financing, we're raising a $5 million seed round at a $20 million post-money valuation. I mentioned the pilots for this year and next, obviously our R&D plans. And we'll have revenues. We can sell credits, so we can generate more than $1 million this year and $5 million next year. So I think I'm right about at time. I'll just leave it there. And should I leave the slides up or take them down?
Oh, I think leaving them up is fine.
Okay.
Thank you very much for the presentation. I think this is the first time I've heard former lawyer turned chemical engineer.
That's
fascinating.
fair.
Career. Yeah.
It has its advantages in the startup space. I think I see a lot of problems that other people miss. Right.
Great. Yeah,
so I guess what would the questions be? I'm curious to see how this resonates with you.
Yeah. So we've actually done the first kind of big question I have. We've done a bio-based materials investment that's going really well. And that's, I think, the other process or thought process around this is to embody carbon in products.
Mhm.
How do you think about that, as a value proposition compared to embodying something and then storing it? Is that competitive? How do you think about, yeah?
It's kind of like an old conundrum with biomass, right? I'd say, well, actually, it's a newer conundrum. Obviously, people have always wanted to use biomass. Let's convert it into something, convert it into energy. Let's make a bio-based material out of it. There are kind of limits to that. Even concrete, you have to be talking about concrete or steel to get to gigaton scale. These bio-based materials are not going to reach that scale, I don't think. And not to say they couldn't ever reach it, but there's always been kind of a built-in issue with biomass as a feedstock, which is the supply chain. It's always a question for any company that they say, we're going to use plant waste or wood waste as our feedstock. And that works great at small scales, but then you need to scale that up. With Tau, obviously, we see the storage of the wood for a long period of time as a moneymaker from a CDR point of view. So, presuming we're right about our costs, like we can sell into the market for carbon removal and make money that way. But we're also in the business of aggregating wood waste. And a wood waste aggregation site is also a hub for biomass utilization. And that's a concept that's being developed in California. And there's a lot of excitement about it. The only catch is that with utilization, a utilization only thinking, you have to match supply and demand. So if you bring in extra supply to your aggregation site and demand isn't there, you've got a problem. Tau doesn't have that problem because we can always just briquette the extra wood and put it in storage and sell another product, the carbon removal product, that way. So we kind of view this as an opportunity. I mentioned we can sell the wood briquettes now. I'd say that's like 1 million, 2 million ton per year global market. So it's not gigaton scale. But the uses of biomass, I would say, are at gigaton scale. There are many, many companies that would like to have the feedstock problem solved for them. Could they just co-locate with somebody who's doing the aggregation? That's what we could offer them.
Got it. So that's within the scope of your long-term vision. Once that market materializes, to your point, excuse the pun.
It is, yes, very much so.
Got it. Yeah, it makes a lot of sense. And then how do you think about, I understand specifically being here in California, like the need for reforestation and wildfire mitigation, but ensuring that your feedstock comes from, a source that's, let's say, good for the environment rather than, chopping down trees for the sake of chopping down trees.
Right. So could we inadvertently encourage, deforestation, that sort of thing?
Exactly.
We're very cautious about that. We wouldn't buy feedstock blindly. In fact, we're not going to buy it at all. The plan is to meet the people doing forest thinning at the forest thinning site. So transportation cost is built into our cost model, and we're solving a problem for them. If nobody shows up to take the waste that's generated from forest thinning, they have a disposal problem, and they either stack the logs up and burn them after a year or two, or they spray chips everywhere. Neither is a really great solution. So I guess we would just pick our sources carefully and make sure we're working with people who are doing legitimate forest thinning. But there is plenty of that going on. The state of California's target is to hit 1 million acres per year in forest thinning. Not quite there yet, but the amounts of wood waste are in the millions of tons that are available. So there's no bottleneck in terms of sustainably sourced wood waste.
Understood. Great. And then the secret sauce is really the process. If you go back to the slide we showed.
Yeah, let's the solution slide is this.
Yeah, so it's the drying and densifying, and is that the
Well, okay. Yes, there is some intellectual property involved in drying because I don't know how much you know about wood, but it is the most energy intensive step in any kind of wood processing. So that's part of our first batch of intellectual property is driving that energy cost down. There is intellectual property around densification. So right now, wood briquetters, this is kind of a standard known technology, but it's only been done at a small scale in the past because nobody cared about wood bricks before. So we do see opportunities to innovate in that space. But the real, I'd say, prize in terms of intellectual property is the container and the monitoring of what's going on inside the container, because you can't just take logs and throw them out in the desert. It might be Death Valley, but Death Valley has a lake right now. even the driest desert in the world gets rain. And if you're not engineering the containment of the wood inside, you don't have a solution. So, and even if somebody went to our container vendor, Fiber Technology Corp, and said, we'd like to buy your water storage tanks and use them for wood storage, they have a problem. A, because those tanks are expensive off the shelf, and B, because those tanks have been designed to sit on perfect foundations. They're not really designed to sit in a real world foundation where it might be gravel and have a little give. So that's the engineering secret sauce that we're developing. And if you don't use our container, I think you're going to be in trouble. Or you could do what our competitor does and just throw it underground and pretend that something underground is going to stay dry, which is remarkable. I'm shocked that they believe this, but whatever. People can indulge in all the magical thinking they want.
Right. So what are the storage requirements specifically? I mean, I imagine you're keeping a certain temperature, a certain level of humidity.
Yes. Okay, so I mentioned 85% as the relative humidity threshold. That's where, you get above 85%, we'd be a little uncomfortable. It's a little too humid. But 85% or below on average is fine. The wood, because it's in equilibrium with the wood. So the equilibrium moisture content that goes along with that is something like 15%. That's well below what it takes for wood to start rotting. We know for our methodology that if we maintain it below 70%, which is kind of more of a desert type condition, 70% relative humidity, like DNA can't even replicate. So microbes and funguses couldn't function at such dry conditions. So we know at 70%, that's it. It's like you're on the surface of the moon. Nothing's living, nothing's growing. Your wood is 100% safe. But I would say over time, we'll develop the comfort level going up to 85%. And really, it's just a matter of monitoring humidity inside the container. You're monitoring temperature. So having temperature sensors, which would be cloud connected. So you're not talking about people physically being on site measuring this. And those can give you a remote cue that something might be wrong. And especially with temperature, if a fire were to start, the fire is not expected to be a concern, but suppose you get some meteor that strikes the container and that does start a fire, your sensor would tell you right away that something has happened. And then you just intervene in wherever that's happening with inert gas, or you flood the container with water, either way.
I hope we don't get a meteor. We'd have bigger problems on our hands, but understood.
Right. But that's kind of how rare I consider this likelihood. Yes, people say, well, won't the wood catch on fire? Well, it's inside a fiberglass container and about polymers, like these things are fire rated to be inside structures. They have the flame spread on fiberglass is extremely slow. So you'd have to have a raging forest fire around the container for days, for this to actually become a problem.
Makes sense.
And our storage sites are not going to be in the forest. They'll be away from the forest in a much, I would say low value land location. So like imagine Tahoe and the Nevada desert right next door. We'd be in the desert.
Right. So you mentioned a little bit on the business model and kind of partnerships and stuff. So you mentioned, you're selling essentially credits right into the credit market. You have an LOI with a reforestation company. Is that an offtake agreement?
Well, it's more of a pilot partnership. So the reforestation company works with landowners you're in California, you might have been approached by them at some point. But if your land has been affected by forest fire, they will contact you and say, we'll partner with you to redevelop your land. So we'll take down the dead trees, replant the forest. But what they discovered in growing that business was that they had tens of thousands of tons of burned trees on their hands. And no way to dispose of them. These trees were completely unmerchantable. So they approached us and said, you have a way of monetizing wood waste. And the reforestation company said, we have the relationship with the landowner who will let you put the storage containers on their land for 100 or 200 years. So that's the connection there.
So what would a long-term partnership look like then? Would that be?
Well, I would say this is mainly geared towards the short term. So in this type of solution where you're trying to store carbon on land, perhaps it affects the solar industry as well. You're always dealing with permitting and the various environmental reviews that go with a project. So this was our way of kind of short-circuiting that for purposes of getting a pilot off the ground, was to bring in the reforestation company. They have the relationship with the landowner. We don't need to worry about buying a piece of land and going through the zoning board and all that stuff that would slow us down. So it's a way of getting a project quickly off the ground. In the future, we could work with them, but I would generally prefer not to be in the forest with this solution. the business model is to move away from the forest, have our own sites. And so I'd say going forward, we probably wouldn't work so much directly with landowners and reforestation companies.
Understood. And then how much, I guess you're in a fundraising process right now, or you?
Yes. So the current raise is $5 million for the seed round. We had our pre-seed round, which we closed last year. That was $1 million at a $4 million post-money valuation. That was all safe notes.
Okay.
Obviously, if you're seriously interested, we could talk about the investors that we had in the pre-seed round. But yeah, it's we view $5 million as the amount of money that helps us execute these pilots. So when you take the funding that comes in from venture capital and you add it to the revenues we can get from selling credits, that gets us through to 2026. So this trajectory, and then by 2026, we finish the seed round, raise a Series A. We're already at break even. I view $150 per ton of CO2 as essentially what high permanence credits are selling for now. Everyone says $100 per ton is the target, but no serious company is selling for $100 per ton today. They actually get paid much more. And then you go, to much larger scales, and the margin opens up, because that's where we really move to overseas operations, ship to that high margin franchising, and get costs way down.
Got it. Excellent. Yeah, thank you very much. Really interesting. I haven't looked at this space too deeply.
Is Zeon involved in fiberglass or FRP production?
No, primarily elastomer polymers.
I see.
Yeah, so we have like composites and this type of thing. Is that?
Okay. Well, in any case, I'm interested to hear your thoughts, perhaps offline, about like this
Sure.
idea of fiberglass as a good material for this use.
Got it. Yeah, thank you very much. Happy to connect offline.
Sounds great. Any more questions?
I'm good. Thank you.
Okay. Thanks so much. Appreciate it. Thanks for inviting me.
Well, that's it for today. Thank you, Dennis, for showing up, and thank you all the people on the West Coast for getting up early. So Forward has climatetechies.com. That's where we have a membership community. I'd encourage everyone to check it out. We also organize VC investor speed dating and fundraising mixers that happens once a month. The next one is coming up March 25th at noon Eastern. All of the guys who have pitched today, I encourage you to connect with each other just to see if there's any way you could help each other out. But that's all I got. Thank you for being here.
Thanks so much for organizing.
Thank you very much.
Thank you very much. It was a pleasure.
Great to be here. All right.